So in this one, we're going to delve a little deeper into naming functional groups with practice. But first, let's talk about identifying functional groups. Let's look at these for a minute. So go ahead and pause. And what are the functional groups as you find them? There may be more than one in a molecule, there may not, but see if you can't identify what they are. So go ahead and pause. Alright, if we want to identify the functional groups, well, we got to remember what the different ones are. And so there were a series. If you have a random R group, OH, you were an alcohol. If you were an R group to a carbon, double bond oxygen to a hydrogen, you were an aldehyde. If you had R group, carbon, double bond oxygen, R group, you were a ketone. R group, carbon, double bond oxygen, OH, you were a carboxylic acid. If you were an R group, carbon, double bond oxygen to an oxygen to another R group, you were an ester. So these were our oxygen-containing functional groups. Let's take a sec and just kind of look in practice and see if we can identify them. In our top left, I've got a carbon, and it has a OH group. Now at first that kind of looks like alcohol, but we have to recognize that when we say R group for being attached to, that refers to basically only carbons and hydrogens. If you have other atoms around, like a double bond to oxygen, that changes your situation. And so both an ester and a carboxylic acid also have carbon-oxygen single bonds. What makes the difference is what then comes attached also. And so we have to really recognize that I can't ignore that carbon double bond oxygen. This is one collective. This is a carboxylic acid. This is not an alcohol and an aldehyde. This is not an alcohol and a ketone, because it mimics exactly what we expect for carboxylic acid. A carbon, double bond to oxygen, and single bond to an OH. That becomes a carboxylic acid. Yes, it sort of looks like it has the individual components of an OH and a double bond oxygen, but if they're on the same carbon, then they are one functional group. As compared to our right side, where I've got a carbon double bond oxygen, and I also have a carbon single bond OH, but it's not the same carbon. Because those are different carbons, they are, if we go and check any of our structures, we don't have any functional groups that look like that. So this is an alcohol and a ketone. It is two separate functional groups on the same molecule. And if we go and we look at our last one here, well, again, we have a carbon, oxygen, hydrogen, and we have a carbon double bond oxygen, but they're not on the same carbons. And again, that doesn't match any of our functional groups. None of our functional groups have things spread out over two carbons so far. So as a result, this is two separate functional groups. Again, we have an alcohol, and this time, well, that hydrogen is important. Yes, I have a carbon double and oxygen, but by having that hydrogen on the carbon, that makes this an aldehyde this time. And so this is an example of a molecule that has two functional groups. All we did was change the position. Right? Our second molecule over here had an alcohol on the end carbon and a double bond oxygen on the next one. Just by swapping those, one of the functional groups has changed what it is. It went from a ketone to an aldehyde. But it's still two separate functional groups. And So an important part for naming is being able to identify what are you looking at. Be very careful that if you've got these large conjoined structures like our double bond oxygen OH, well, if they're on the same carbon, that is a carboxylic acid. But if they are on separate carbons, that is not a carboxylic acid. So I then have to start looking at, well, what does each of those parts look like? What does each of those parts match? Alright, let's give a little practice to naming. So if you have multiple functional groups on a molecule, other than, say, like double bonds and triple bonds, the AN, EN, and YN, that can be included in any name. But if you have an alcohol and a ketone, if you have an alcohol and a carboxylic acid, while there are ways to name that, that is not part of this course. So you will not be asked to name any of these molecules that had two separate functional groups. That isn't part of what we're doing. Alright, let's give a shot. Try and name that, and then come on back. Alright, well, these are carboxylic acids. In fact, I have two of them. So one of them has to be carbon 1, arbitrarily we'll choose there, 2, 3, 4. So we're going to have a 1 and a 4 position carboxylic acid. So the end of this is going to be 1,4 dioic acid. Remember, the suffix is oic acid for carboxylic acid. It's 4 carbons long, so it's going to be a bute. Carbon-carbons are all single bonded. It is a butane. So there's a butane 1,4-dioic acid. And then I have methyl groups. I have 4 of them. I have to tell you where they're at. They're at the 2, the 2, the 3, and the 3 position. There's 4 of them, which is tetra, and then they are methyls. Methyl. So 2, 2, 3, 3, tetramethyl butane 1,4-dioic acid. So this, it's an aldehyde. We can see that as a double bond oxygen and carbon. That carbon goes to hydrogens on the end. This aldehyde also happens to contain an ether. Now, while ethers on their own can be named, we did teach you about subgroup ethers. And so remember the oxy ending. If you don't remember that, go back and watch the ether video really quick. But go ahead and give this a shot, and don't forget we've got a double bond in here. So we have several different pieces that we're going to try to bring together. So give it a shot, name it, and come on back and let's work through it. Alright, well, if you're back, my aldehyde is my functional group, so I must have that be carbon 1, which makes that carbon 2, carbon 3, carbon 4, carbon 5. And so the aldehyde is the most important. It has to be the lowest. It would beat out the double bond, even if there was another way to try to number it. So the aldehyde is going to be 1. The double bond will then be wherever it has to end up as a result. So I have 5 long. So this is going to be some form of pent. There's a double bond, however. So it is a pentene. And we need to tell you where. It is a pent-2-ene. And it's got an aldehyde, so it is a al. Pent-2-enal. Now we could say it's at the 1 position for the aldehyde if you'd like. 2-ene, 1-al. But aldehydes, remember, have to be at position 1. If you have an aldehyde, it's going to be at position 1. So we often leave that 1 out. Well, I've got other parts. I've got a methyl and a methyl subgroup, and I've got that ether to deal with. And so I do have a methyl, another methyl. And ethers, if you remember, you talk about how long the chain is, it's one carbon, and you call it oxy. So this is a meth-ox-E, if you want to mention it as a subgroup. So now we need to string it together. Well, meth-Y versus meth-O, meth-oxy is alphabetically lower. It is a 4-meth-oxy 2,3-dimethyl pent-2-ene 1-al. And so this molecule, the name gets quite large, but if we want to break down the parts of it, at the 4 position is a methoxy. So we just tell you, hey, there's methoxy means I have an ether with the extra carbons coming off it being 1 long. So meth for 1 long. So I have a 4-methoxy. At the 2 and the 3 position, I have methyls. And so they are dimethyls. The main chain itself is 5 carbons long, so it's a pent. At carbon 2 is the start of my double bond. At carbon 1 is my aldehyde. Our main chain comes in on the top. If I try and draw a line through the double bond, it comes in above and it goes out below. They are on opposite sides, which means this is a trans double bond. And so this is the rather long name for, it honestly doesn't look like that big a molecule. But each component of it is fairly systematic. What's the position? What's the thing on that position? Put all those parts together to make the big long name.